Hey guys, in this review video I'm going to show you how to answer the 3 questions that I posted in this announcement for the test review. First one I'm going to do is construct a regular dodecagon, which we need to know is a 12-sided shape polygon, and it's regular. So we're going to be using its interior angles to do that. Then we're going to construct one of the congruent triangles that make a regular 25gon. And then the third question, third example will be me solving a problem like this, finding all these angle measures based off of what we know. Okay, so let's get started here. First one, construct a regular dodecagon using its interior angles. First thing we have to do is figure out the angle sum of all 12 angles, what they would add up to. So to do that, remember we have our polygon angle sum theorem. That tells us our sum. So n in this case is going to be 12. So if we take 12 minus 2 times 180, 12 minus 2 is 10, and 10 times 180 I think is just 1800. So in a dodecagon, all the angles are going to add up to 1800. Then we take that angle sum and we divide it by how many angles there's going to be. So in a dodecagon, there's going to be 12 angles. So let's pull up a calculator and see what that angle is going to be. So we're going to take 1800, divide it by 12. You get 150 degrees. So in a regular dodecagon, each interior angle is going to be 150 degrees. So in GeoGebra now, start with a segment. That'll be like a side, right? We're going to grab our angle with given size tool. And now I'm just going to click on A. Since I'm clicking on B second, this is going to be where my vertex goes, and we're going to create an angle that's 150 degrees from the segment. So let's just type 150. So there's one of our points there. And again, that angle with the given size tool means that A just got rotated to A prime, so the distance that A prime is from B has to be the same as here. So we're going to guarantee our equal segment length with this tool. So because this is going to be a dodecagon, we're just going to continue this until we get all 12 of our vertices up. Looks like I just got one more. And if I just check this real quick and rotate, we get a point right where we started. So then to finish off our polygon, this is our regular dodecagon. It's got 12 sides, 12 angles. We constructed it by using the fact that all the interior angles are going to be the same in measure. Alright, so there's our regular dodecagon. So that's our example for constructing a regular dodecagon using its interior angles. Now construct one of the congruent triangles that make a regular 25gon. Okay, so if we have a 25gon, let me see if I can make a 25gon. Nope, I can only go up to 16. So in a 25-sided shape, we're going to have 25 angles. So if you think about a center point, we're going to have these 25 angles going off, right? So there's going to be 25 of these equal angle measures, and then what we need to figure out is what one of them is. So it's the full revolution, so 360 degrees around our center point. And we're just going to divide by how many sides or how many angles the polygon has. Remember, for every side, there's an angle, right? For this side, there's this angle. For this side, there's this angle. So if we take 360 and divide it by 25, we'll see what our little angle within here is, because we're taking that full revolution and we're breaking it up into 25 little groups. So let's do this. 360 divided by 25. 14.4. So that's going to be our angle in here, which is 14.4. So now we have to understand that each of the little triangles, these congruent triangles, are isosceles because this segment is congruent to this, which is congruent to this, and all the way around, right? So these are just isosceles triangles, and we're going to make this vertex angle in here 14.4 degrees. So let's try this out here. Okay, so we need an isosceles triangle. The easiest way to do that, I'm going to go a circle, create a radius, and then any other radius that we make will guarantee to be the same length. So this will make our isosceles triangle for us. use the angle with given size tool. My second point that I got to click on is my center, because that's where we're going to make our angle at. So if we go 14.4 degrees, there's our little slice. And so the piece is all that we have to make, and there's our answer. Okay, so we made this isosceles triangle, and that angle inside there had to be 14.4 degrees. So to submit this, you would just submit the screenshot, but if you want to check it to make sure you did this right, grab your regular polygon tool, click on your 2 points that are on the circle, 2 vertices of our shape here, and there's going to be 25, I believe, right? So if I click OK, boom, you can see that that's just one slice of the remaining 24, right? So 25 total congruent little triangles to make a regular 25-gon. So that's how we do that. And then the third problem is going to be this angle problem here. So let's get started. First things that I notice when I look at this, we got parallel lines, and we got some congruent angles, 90 degrees. We don't have any congruent segments, so we're not really thinking that isosceles triangle stuff, but let's see here. Okay, A has to be 116 because it's vertical to this 116. Alrighty. D and this 98, since these are parallel, these lines, 98 and D are what we call same side interior, which just means that they're supplementary to each other. Because if you think about this 98 here, this angle above D would be 98 also, right? So I'm just going to write that here, which means that these have to add up to 180. So same way of thinking, either these add up to 180 or these add up to 180, right? Doesn't matter, but D must then be 82 degrees. Okay. Same deal with A and B here. These are same side interior with this line being a transversal, so they're supplementary. So if we take 116 minus 180, or 180 and subtract 116, we're going to be left with, I believe, 64 degrees. So that's what B must be. Okay. Let's see. To get E and P, if we know one, we know the other because they're congruent to each other. If we think about, this is 64 degrees, this angle up here is 64 degrees, and I'm going to look at this quadrilateral right here. Okay, so this quad right here. We know that all 4 angles in a quadrilateral add up to 360 degrees, right? So if I take 98 and I add it to 64, so 98 plus 64, we get 162. So we know that if we take 162 from our total, so I'm going to take the 360, the 4 angles in a quadrilateral, minus 162. The remaining angle measure for these two have to be 198, and if they're congruent to each other, they have to be half. So I'm going to divide that angle sum by 2. So these are both 99 degrees, right? So if you took 99 plus 99 plus the 98 plus the 64, we should get, hey, check that out, 360. So we know we did that one right. Okay. Let's see what else we can do. It seems like there's a lot of quadrilaterals and things going on in here. If you look at this angle being 90 degrees, it's same side interior to C, so C must be 90 degrees also. Okay. Let's move up into this quadrilateral if you see this right here. Okay, this quad right here, actually, yeah, that is a quad, isn't it? We got 1, 2, 3, 4 sides. So again, 36 plus 116 plus this angle right here, which must be 90 degrees also, because this is 90 degrees. So 90 plus 116 plus 36 plus n have to equal 360 degrees. So let's do the same thing here. Let's take our total of 360, and I'm going to subtract off this 90 that we know. I'm also going to subtract off the 116 that we know. And I'm also going to subtract off the 36 that we know. And since I'm taking away 3 out of the 4 angles from our total, what's left must be the measure of n, which looks like 118 degrees. Okay, let's get m. So if you think about this 106 plus this 118 plus m, they make a full circle here, so the three angles must add up to 360 degrees, right? So let's take the ones that we know. Again, let's take our total, 360, subtract off the ones we know. So I'm going to subtract off 118. This would be the same thing also as if we added up 118 and 106 and subtracted the sum, but that's okay. So it looks like M then, what we're left with must be 136. So this is 136 degrees because all these three angles right here have to add up to 360 degrees. Okay, let's see what else we can do. Down here, I can use that 360 degree sum here, but we need to know one of either F or G. Let's see if we can figure out, let's look at this. This looks like a pentagon down here, right? So this is 1, 2, 3, 4, 5 sides. So we know that all 5 angles in a pentagon, if we use our polygon angle sum theorem, you'll find out that it's 540 degrees. So we need to know 4 out of the 5 to get F here. Well, if this is 64 degrees, this would be its supplement, right? So this would be 116. It's also corresponding to 116 up here. So if this is 82 up here, it corresponds to this angle 82 down here. So hey, we know all 4, we know 4 out of the 5, so we can actually get F. So I'm going to take the sum here. Let's add these 4 angles we know up. So 82 plus 116 plus 116 plus 138. So if I hit enter, these 4 angles add up to 452, but in a pentagon the sum is really 540. So I'm going to take 540 minus 452. So that means F must be 88 degrees. Alright, now that we got F, we've got 2 out of the 3 that add up to 180, or excuse me, 360. So if we take 88 plus 122, that's the sum of the 2 angles that we know. We're going to subtract that from the total of 360. So even if I go minus 360 now, it doesn't matter if it's negative. I just know that this is going to be 150 degrees. Okay. So let's see. Let's move down to H here. H and the 77, they don't make a straight line, so we can't use a linear pair concept. But I bet you because this is 90 degrees, this has to be 90 degrees. And since this angle is 64, this is 64, right? They're vertical. So we know 3 out of our 4 again. So let's go ahead and take our sum. Let's go 64 plus 150 plus the 90. There's the 3 angles that we know. Let's subtract that from our total. It's a quadrilateral, which add up to 360 degrees, all 4 angles. So if I click equal, that tells us this angle is 56 degrees. Okay, last one's here. Let's get J and K, and we're done. So let's see. N is 136. This angle right here must be 90 degrees. So we know 3 out of this quadrilateral right here, 3 out of the 4. So we can actually get this angle. Then we know K because they're vertical. So if we take 90 plus 136 plus 60, 90 plus 60 is 150. 150 plus 138 is 280, or 136, excuse me. Let's just do this. 90 plus 60 plus 136. Add up to 286. It's a quadrilateral. The sum is really 360. So I'm going to take that total from 360 and we'll get 74. So we know that this angle is 74, therefore K is 74. And now we know that K is an alternate interior angle to this angle here, which is also then 74. Also, these are corresponding. So if this is 74, J must be the other number that adds up to 180, so this must be 106. And we got all of our angles. So I hope that made sense. Go through that video a couple times if you need to, and see if you can do that as well. Good luck, guys.